Hello everyone, this is the video lecture for College Algebra Math 1314 Section 3.2 Polynomials. So let's talk about polynomials. Well, you can see I already answered the first one for you. The answer is yes. So is this a polynomial? Yes. But why is this one a polynomial? Well, polynomials have, if you're looking at them like f of x kind of stuff, they have positive integer powers. Positive integer powers. And so I'm looking at each power. Is this a positive integer? Yes. Is that a positive integer? Yes. So yes, it's a polynomial. Here's another example. Let's say I had x cubed minus square root x. Is that a polynomial? No. This is fine, but this is a half power, and that's not an integer. Okay, what about if I had x cubed minus x to the negative 2? Again, the 3 is fine, but this negative 2 is not positive, so that's not a polynomial. All right, so here's a graph, and it says, is this a polynomial? You're going to say yes. And the reason why is because it's smooth and continuous. Smooth, continuous. And that's basically the definition for what polynomials would look like. And let's just say that there was another kind of graph that had some sharp points on it, and then a discontinuity of some kind, a jump. Yeah, that's not a polynomial. Anything that has sharp corners, or if it has the jumps or anything like that, it's not a polynomial. Okay, so that was good. Now let's graph some polynomials. So first off, I gotta say, if you're wanting to graph polynomials, there's an easy way to do that. You can use a calculator. So Desmos.com or some other such graphing calculator could easily graph all these for you. But there's actually something further that we need to learn here in order to get these things done and learn more about the future, about what we're going to have to use as some tools. And it's called end behavior. End behavior. And this takes its own kind of lesson on the side, I suppose. So there's going to be 4 different templates, 4 different prototypes that we need to look at. And I'm just going to make an example for each one of them. Let's say that I got a positive x squared. And it's going to look something kind of like this guy here. So positive is in the front, even is on the power, and I'm only concerned with the arrows. Oops, I was wanting to get a red color. The arrows. I'm only concerned about the arrows. And the arrows, you can see, are both going up. So rise left, rise right. And I don't think I'm going to write that down for each one of these because, for one, it's really sloppy looking. But another is that it takes a lot of time. But the idea here is that they're both going up. I don't care about the wiggles in the middle. I care about the arrows. Positive front, even power, they're both going up. In opposition, we have something like this here. That would be negative x squared. Notice that we got a negative in the front, and we have an even power. I'm only concerned about the arrows. They're both going down, so that would be falls left, falls right. And of course, here in a few minutes, we're going to have some other stuff going on. So positive goes up, negatives goes down, even goes the same direction. So here's another prototype. What about positive x cubed? And so this one kind of looks like this. I only care about the arrows, so notice that it's going to be falling on the left and rising on the right. And then the last one, let's just say negative x cubed. It looks something kind of like this. Again, I'm only caring about the arrows, rising on the left and falling on the right. So that's the language that you're going to use in the program that you have for your homework, etc. So there we go, end behavior. So what I'm looking for here is I want the biggest power, the degree, I guess what I like to call the boss, and he's going to determine which one of these is. So I'm looking at the biggest power, the biggest degree, and he's going to determine which one of these it is. So for an example, when I'm looking here at this first one, notice that he is the biggest power. I like to call him the boss. Oops, boss. And so he's the boss here. He's going to determine what else is going on. And I want to basically say that the x squared doesn't really matter in the end about the end behavior. And so we got a negative even. And so in the end, it's going to look something kind of like this. Now, that I don't know all the wiggles on the inside. There could be some wiggles going on, and that's perfectly fine. The point of this problem, though, was actually to find just what the end behaviors are. So I can't give you a perfect graph without actually graphing it, and I would have to grab a calculator to be able to do that perfectly. But the idea is that it's probably going to be something, like a W, something kind of like this. And again, they're both going down. I don't know what the wiggles are doing. That's not a perfect graph, but it's close enough for what we need here. Notice here we got a positive x cubed. Again, anything else doesn't really matter. He's my boss. Positive odd was meaning he's going to go on falling on the left and rising on the right. And again, there's going to be some wiggles in there. If you want to make it a little bit more wiggly, that's fine. There's some wiggles. But again, my arrows are important here. This one's actually a lot easier. You could expand this out by foiling it and all that kind of stuff. Just quickly doing it there. And you could see what the boss would be. He's a positive x squared. And so in the end, it's going to be a parabola. And he's touching at 3. So we've actually covered that before back in a previous section. And so rises left, rises right. And then finally, we got a negative odd. And so a negative odd actually is going to look something kind of like this. Again, there's a lot more going on here, so let's just go ahead and add some more wiggles. Again, I have no clue what the wiggles are doing, but it's just close enough. You pick which one it is, and there you go. So multiple choice, that's essentially what we're working with here. Not too bad in the end. Okay, let's keep going. Number 4. So they want now to find the zeros. And so I need to find the zeros of this function and continue on. So the zeros are when you set the whole thing equal to 0 and you solve for x. And this is super easy because we could just look at it and get the answer. So x minus 6 is equal to 0. I mean, we're doing it the long way here. You already know the answer, don't you? And so x equals 6. You already knew that. I'm just reminding you. So what will be the answer here? It's going to be a negative 4. You always just switch the signs. And so what you need to put in the box is 6, negative 4. That's good enough. So we got the zeros. But now they're asking about multiplicities. And multiplicity is how many times it occurred. How many times did a single 0 occur? So let's look back at the x equals 6 and the x equals negative 4. And I want to know how many times in the problem. Well, the 6 only happened once, and you can tell because there's a 1 there. And so I'm going to write mul1 for multiplicity 1. I'm just kind of shorthanding it, really. And then how many times did the 4 happen? Well, negative 4 happened twice. You can see the little 2 there. If you were going to expand it out, it would look like you had 2 of those guys sitting side by side. So I'm going to put a little multiplicity of 2 for that one, okay? And again, this 2 doesn't really matter, doesn't change anything, so you can just eliminate him entirely. So these are the multiplicities, but how do they want you to put it in the box with the program? That is a good question. They're going to have some very tricky language that we're going to have to kind of navigate. What is the smallest 0 and the biggest 0 and that kind of thing? Well, and I'm just going to replicate that just a tiny bit if that's okay. Let's just say that I had the smallest 0. The smallest 0. What was the multiplicity equal to? And what they're asking for is the most negative. And that would be the negative 4 here. So they're saying x equals negative 4. That's my 0. So what's the multiplicity associated with it? 2. Okay? And then we're going to say the largest 0. Find the multiplicity. And so that's the most positive. In this case, it would be the 6. Not because 6 is bigger than 4, but because 6 is greater than negative 4. Like on a number line, this is on the most left side, and that's on the most right side. Anyways, x equals 6 with the multiplicity, you put a 1 in there. So most positive. And it is a very confusing language. Just kind of work around it. So those are both the actual answers for right here. So then the last one, I'm going to use a different color so we can differentiate. It says crossing or touching. Well, the reason why we're doing multiplicities is to be able to see if they cross or touch the x-axis. So what they imply here is crossing or touching x-axis. That's what they're asking for. And so if you have an odd multiplicity, like this number right here, that 1 is an odd number, you're going to cross right through the x-axis, like whoosh. So you go right on through it, and that's it. But the even multiplicities are going to only touch it. And so what you would see here is like a bloop, and it would touch and go back the way it came. So again, how are we supposed to do this? I'm going to say touch here. I forgot to write that. Sorry. Touch. So these are your answers, cross and touch right there, because this multiplicity is even or odd. I did not look at the 0. I did not look at the 0. The 0 is not what I'm asking for here. I'm asking for the multiplicity. Is that even or odd? So how the homework program is going to display this is going to say, where is it crossing x equals what? And so we're actually having to go back to part A's answers to be able to input them. But now I'm looking at what I have here. I know that this right here is going to cross. I already know the answer. So what I need to do is take this number and stick it in there. And then they're going to ask, okay, so where is it going to touch? And I already know the answer. It's right there. So I'm just going to plant this answer here, this -4 in there. So I'm using the answers from part A, but I have to rearrange them according to what I had in part B. I know it's a little strange. In the end, we had the answers a long time ago. Okay? Focus on the math, not on the math program. Okay. And this is a similar question, so let's go ahead and do it. So first off, I need to factor this thing. They all have an x in common, so that's at least something. 20x, and then plus the 144. Factor that down to 12 and 12, both being negative. And if you want to really look at it, that would actually be x minus 12 squared. Okay. Let me use a different color now. So what we have here is x equals 0 is my 0, and I also have x equals to 12. And I'm going to ask, what's the multiplicity? How many times do you see this happen? One time, multiplicity of 1. And this here, how many times did it happen? 2. This number here is odd, and so therefore we're going to cross. This number here is even, so therefore we're going to touch. And really what you have is the entirety of your answers here. I'm going to try to put this a little bit more succinctly, I guess. I don't know. So zeros, what do you put in the box? You put a 0 and you put a 12. And then it says, what's the multiplicity of this and that, the largest and the smallest and the largest? This would be kind of sloppy here. Well, the smallest would be the 0 here. And so you're going to put a 1 that's associated with that. I guess you could say this is x equals 0. This is x equals 12. And so what's associated with the 12 is a 2. And then we already know the final answer. So they're going to say, okay, where's it going to cross? And we already know the answer for cross. It's going to be that 0. So you put a 0 in there. And then it's going to ask, hey, where's it going to touch? And we already know where it's going to touch. You just put that 12 in and you're done. See that how the answers for part A go into part C, but because of part B. Okay. Do a couple of them. I'm sure it'll be fine. All right. New type of question. This one asks for a lot of different things. And so let's go through it. First off, they say, what's the end behavior? Well, this is a good question, actually, because it doesn't look like there is a boss. There's not something singled out. I would have to FOIL the whole thing. And I don't want to. So what I'm going to do is take the leading terms and I'm going to multiply them together like this. And so if you notice, I got x squared, x cubed, and x. If I went off to the side, that would actually be 6 x's in the end, right? 2, 3, and 1 more makes 6 x's. And, you know, we can keep going, but again, none of that even matters. I'm looking right here at my boss, and he is a positive even. Positive even. And so he's going to be rising on the left. Oops. He's going to be rising on the left and rising on the right, and I don't know, some wiggles in the middle. I don't really know. I don't really care about the wiggles. I'm only caring about rise left, rise right. So in behavior, depends on how the program's going to ask it, but you could say rise left, rise right. Of course, that would be multiple choice. So there you go. X-intercepts is whenever we're solving for x, and we just did this on the last problem. Here we got 0. If there's no number next to it, it's 0. Here we got 3, very simple. And here we got a -5. And so you put those in, 0, 3, -5. Does not matter the order, it should be fine. Y-intercept, that is actually when you plug in 0. So you're going to plug in x equals 0. When you do that, you actually get 0 in it. It's kind of funny. Whenever you got a 0 for an x-intercept, you're going to have a 0 for a y-intercept as well. It's just how that works. And then they say to graph it. Well, the thing is that I'm not given enough information just to know what to do here, I suppose. So let me try to graph it as best I can. I have a 0 at 0, 1, 2, 3, and then at -5, 1, 2, 3, 4, 5. Awesome. So that's great. The problem, and I got my end behavior, so it's going to rise and it's going to be rising. But am I touching this one? Am I crossing this one? What am I doing with each one of these? And so I need to go back and look at each one of these zeros individually and see if I'm going to cross or touch. So this guy, 0, how many times did he happen? Twice. That's an even number right there. That's an even number. So we're going to touch there. We're going to touch right here at this one. Okay, for the 3, multiplicity of 3. And that's an odd number, so we're going to cross. So right here, we're going to cross. Just kind of writing it down so I can figure it out later. And then the last one here, the -5 has a multiplicity of 1. 1, that's again an odd number, so it's going to cross. So this guy here is also going to cross. So I want to connect the dots and fill it all in. So here we go. Go down, it says touch, bloop. Come back up, and then this guy I'm going to cross through, and then here I'm going to cross through as well. And there you go. We finally got our graph. Awesome. So that's not terribly hard, but again, could you use a calculator to help you get some of this information perhaps, or at least the graph? Yes, most certainly. And I recommend it. Okay, so we got a big word problem here, and it is intimidating, but it's not difficult. X is years after 1970, and they want to know what's going on in 2010. Well, if you notice how many years is going to be passing there, that's going to be x equals 40. So what I do is I plug in the 40 into all this right here to get an answer. And so, let me grab a calculator here, because this will take a little bit of time here. Give me a second to start typing all this stuff in, because it's going to be a big one. Okay. Wow. Yeah. Okay. So I have 48,000 for the first one. Okay. I'm going to keep going here. At least I hope this is right. I have 48 for the other one, 48,000 for the next one, and that's a negative. Okay, that's kind of scaring me a little bit. And I got 35120, and then I got 37840. Well, these guys obviously will cancel, and so let me find this one here. Subtracting. Yep, that sounds about right. I got out of all this thing here 2720. Yes, that sounds right. Oh, of course I can't write it down correctly there. 2720. Cool. All right. And now that asks for an ordered pair, and this is actually very simple. What they want is the 40, 2720, just like that. This is your answer with the parentheses. They're wanting an XY point. So that's what an ordered pair is. We got the X, got the Y value. There you go. All right, and so they say now compare with the chart that we have here. Notice that their chart had 2700 and I have 2720, and so we're off by a little bit. In fact, mine would be over some amount, right? Mine's over by 20. And so the reason how I got that is I take mine and subtract it from theirs, and I got a 20, and mine was more, so I wrote over. So over, you click it, you put 20 in, and there you go. So cool. There's a lot more words to that problem, but that's not really affecting the problem itself. The main thing is right here, you're just doing this math. So that's all I got. Thank you very much, and have a great day.